Now that a long-awaited course of my personal finance has come to fruition, I do something in all of my courses which provide a grand summary and at the end a host of practice problems and answers. Let's do some. We all live in an after-tax world, so in this case, let's say you pay a quarter on taxes and you earn 12%, then you'd make 9% thereafter. On the other hand, the tax-free would stay at 7%. Likewise, we live in the present, and we'd like to find out the value of various dollars in the future now. Well, we have an annuity that's a stream of annual payments. You have a single sum at a particular time, and you have a perpetuity that goes on forever. Likewise, we live in the present, which is to say we can take the value of a dollar today, given its future, maybe as a single sum at a particular point, or an annuity, a stream of annual payments, or maybe a perpetuity if it went on forever. In all of these cases, we'll use $5,000, year 8 at 6%. Well, a single sum would be worth about $3,100 using, say, a table figure of 0.627. The annuity, years 1 through 8, would be worth about $31,000 using the annuity table 6.21. On the other hand, for a perpetuity going on forever, we're going to divide by that 6% as a decimal 0.06, getting some $83,000, which is to say $83,000 at 6% would give us $5,000 a year forever. Well, we can use present value, particularly in a case of a bond valuation, because they use both an annuity, that's the interest payments, and the single sum of face value. And by convention, we always do this as 100 percentage points of face value. So we have a bond that pays 6% interest and matures in 7 years, and you'd like a 5% yield. Well, it pays more than what we want, so we should get a premium value above 100. So we take that 6% interest payment, but at a 5% discount rate, it pays more than what we want, and that factor is 5.786. And then we take the single sum, also again at 5%, at factor 0.711. Well, it's 34 plus 71, we get 105.8 and some change. And notice, again, it trades at a premium. Next is the EOQ, the economic order quantity. And it answers the question how much money is optimal to take out of an ATM or how much dog food you should buy. Well, it turns out it's King Tut overseas. My mnemonic device for the square root of 2 times the annual usage times the transaction cost per order divided by the carrying cost per unit. And in the case of money or its equivalents, that's a percentage point as a decimal. Turns out it's the minimum of the total cost, which is the average quantity divided by 2 times the carrying cost plus the number of orders, which is the usage divided by the quantity times the transaction cost. Okay, say you use $100 a month in stuff. Their transaction cost is $3 per order, say to go to the ATM, or the cost of the ATM. The interest rate is 8%. How much should you withdraw? How often? And what's the annual cost? Well, plugging into King Tut overseas, we have 2 times 100. Remember, it's times a month, so we're going to annualize it by multiplying times those 12 months, times the transaction cost per order of $3, divided by 8% as a decimal, 0.08. Take the square root of that whole thing, and you get 300. Well, how many trips would that be a year? Well, that's 4 times. And we can check our work by noting that the average of the 300 is 150 times 8%, plus the number of orders, here again 4, times that transaction cost per order of 3. And what I mean by check our work is while the total is 24, notice that the 2 separate terms are both 12 and 12, and that's always the case when you have an optimal. Let's take a look at a graphic and you'll see they both cross for the two components being equal at the minimum. Let's go back to present value, but this time with some shortcuts. Everybody loves a shortcut. Suppose we have an annual compound percentage rate, and we want to know it for a painting bought 32 years ago. Then it was $200, but today is worth $3,200. Notice it's 16 times in value, which if you notice is actually 2 to the 4th power. Let's see, 2, 4, 8, 16. So that means it doubled 4 times in that 32 years. So that means it doubled each 8th year. Now there's something called the rule of 72. That means the rate as a percent times the number of years will equal the number 72 if it is a doubler. Well, let's see. 8 years into 72, 9. That means 9%. Probably one of the most relevant personal finance questions is, where do I put my money? Bills, investments. Some self-appointed foolish gurus say pay bills first. No. Some say pay small debts first. No. Let's do these all after tax and sort them by that after-tax rate. Well, we have 3 debts and 3 investments. I suppose you can read them just as well as I can. So we have the auto loan, no tax deduction. Credit card, no tax deduction. Home loan, yes. So we're going to take that 6% and make it 4%. Because the tax rate is 1/3 at 33 odd percent. Well, let's see our investments. We have a pension, deferred, 9%. We have a no tax deduction on that Roth IRA at 12, and the traditional is deferred at 12. Here for the deferreds, I'm going to use a very gross approximation because it is deferred. Usually around 20 years you get half the present value. Work with me here. So instead of using that 1/3 for the deferreds, I'm going to cut that in half again and make it a 1/6. So we'll keep 5/6, so to speak, and therefore we adjust that pension and the traditional IRA, and we now have our rankings listed in order. Credit card comes first at 18, but look at that. The Roth IRA, tax-free, remember, no adjustment, 12% comes next. Then the traditional IRA, 10%, because that's actually 12% deferred. Next is the auto loan, no longer a tax deduction. Your pension is deferred, so I'm going to use that 1/6 rate. Now it's 7.5. And the home loan, don't pay that off because it's only costing you 4% after tax from 6% at a 1/3 tax rate. Let's do some weighted averages, and here's an example. We have a portfolio, $4,000 in LMU earning 8%, $8,000 in XYZ earning 6%, and another $4,000 in ABC earning 4%. First, we got to do the weights, the proportions that add to 1. Well, that 4, 8, and $4,000 add to 16. So we have 4/16, that's a quarter of 8. 8/16, that's a half of 6. 4/16, that's a quarter of 4. That's 2 plus 3 plus 1. We get a 6% average weighted portfolio return. Let's do an expected value of a gamble, and we should note the formulas are really quite similar to a weighted portfolio return, except the lottery ticket has only positive percentages. If you have a negative debt in a portfolio, that would be a negative weighting. Here we have an example. We have wins $500, 1% chance, $200, 2% chance, and the ticket cost you $10. Well, that's 1% of 500 plus 2% of 200 minus $10 minus $1. Well, here's a perfunctory question, and while it seems kind of simple, it's also kind of relevant when you compare it to other ways to save money. You got a 15-gallon tank, and it's empty. There's a station charging you $6.20 nearby, and there's another one charging you $5.80 down the block. What if you wanted to figure out what the annual savings are? We'll take a 2-week vacation, so using a 50-week year. Well, the difference between the two prices is 40 cents a gallon, And that's times the number of gallons times the number of weeks. That's $300 a year. And we've seen elsewhere that whether you're cutting your own hair, mowing your own lawn, getting rid of the cable TV or the cell phone, those are the biggies. And it turns out this is a big one too with Dr. C.